Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson. All right, hello and welcome everyone to another episode of It's a Controls Problem. I'm your host, Charles Johnson, and I'm with, as usual, the great Matthew Vanberg. But we do have a special episode, and actually, really a series of episodes. This is going to be the first one in a few. I don't know how many of this is going to be, but I really think that the history of controls, I think, is really important to understand from a fundamental perspective of how did we get from where we were, like where we are today, how did we even get there, and how it all started.
A Tale of Intelligent Buildings, Part 1. The air in the burgeoning cities of America is a thick concoction, a heady brew of coal smoke, horse manure, and the metallic tang of progress. It's a scent that clings to the wool suits of men like Warren Johnson and Albert Butts. Step outside onto the bustling streets of an American city and the world is a symphony of controlled chaos. The clatter of iron-shod hooves on cobblestone is a constant rhythm, punctuated by the shrill clang of a trolley bell and the distant, mournful whistle of a locomotive. The buildings, monuments of bricks and carved stone, rise higher than ever before, their grand facades often smudged with the soot that is the unavoidable byproduct of the nation's insatiable appetite for energy. This is an era of exhilarating, almost dizzying transformation. The memory of the Civil War is beginning to recede, replaced by the clangor of industry and the hum of new ideas. The future, it seems, is being hammered into existence in workshops and laboratories, tangible things that can be patented and sold. And yet, for all the burgeoning modernity, life is still profoundly tethered to the limitations of the past. Inside one of those grand new office buildings, a drafty chill snakes through the corridors, a stark reminder of the primitive nature of comfort. This is the America of the late 1800s, a nation standing on the precipice of a new age, its feet still firmly planted in the mud of the old. It is a time of immense promise and profound limitation, a world where the future is not a distant dream, but a tangible thing being forged in the fires of invention. The air may be thick with the grime of the present, but it is also electric with the possibilities of tomorrow.
So, before the advent of automated controls and thermal management in commercial buildings, it was a very labor intensive and imprecise affair. So the entire process was all open loop. And what I mean by open loop is that there was a janitor and he was armed with a coal shovel and literally like a wall thermometer that would just manually adjust the furnace dampers. And so the result was this constant oscillation between overheating and then overcooling. And it was very disruptive and inefficient. There was a fundamental problem with control and comfort. And it really wasn't until 1883 is where we came up with well, not we, but the first significant solution came about. And it actually wasn't from an engineer with an engineering degree at all, but rather an academic. And that actually came from Warren S. Johnson. He was a professor in Whitewater, Wisconsin, I believe. And he patented the electric telothermoscope. And basically, this device was a bimetallic coil that completed an electrical circuit at a set temperature. And it was, in essence, basically the first building sensor. And while it didn't directly manipulate the heating system, it acted rather as an annunciator which signaled a specified room need for heat to the basement furnace operator. And it was the first really primitive nerve impulse of the modern smart building. And 2 years later, that's when Johnson founded the Johnson Electrical Service Company, which is now the global giant for Johnson Controls, which I think is actually amazing. And that commercialized his invention. So his innovation, however, only addressed really half of the equation, which was the sensing portion. The actuation, or really the closing of the control loop, was perfected by another inventor. And so it was in 1886 that I believe he was out of Minnesota. And so his name was Albert Butz. And he patented what was actually called the damper flapper. I know that it actually sounds quite hilarious, but that's actually what it was called. And so this was the first true thermostat that we had. And it was not only the device that didn't just signal a need, but executed an actual command. So, by linking the thermostat to a battery and a motor, Butz's invention could automatically open and close the furnace damper. So, it was really the birth of true automated building control. And Butz's company, through a series of mergers and acquisitions, eventually became the other foundational pillar of the industry, which was Honeywell. And I think it's a striking parallel that the two companies that would dominate the building controls for the next century were founded within 2 years of each other, perfecting the sensor and the other one perfecting the actuator. And so we all know of Johnson and Honeywell, but that's really where their humble beginnings actually began. The earliest 20th century saw the next major leap in building and environmental control here. And so in 1902, it was actually a young engineer, and his name was Willis Carrier. He was tasked with solving a humidity problem at a Brooklyn printing plant. He developed a system to pass air over chilled coils. And so he called it manufactured weather, which is now what we actually call air conditioning. And so this invention fundamentally changed building design and functionality, which created a new and complex system to be managed, which was HVAC. To control these increasingly large and heavy mechanical systems, the industry turned not to the fledgling electrical grid, which was often unreliable and that really lacked power for significant mechanical work, but it actually looked to compressed air. So it was Warren Johnson himself who patented a pneumatic control system. And this might seem counterintuitive for an electrical pioneer, but it was a pragmatic engineering choice. Pneumatics actually provided the necessary force to actually move large valves and dampers reliably. A central compressor distributed air through a network of copper tubing, and a small change in air pressure from a thermostat, standardized at 3 psi to 15 psi, could actuate a massive piece of equipment. This particular standardization had a profound and lasting impact. It helped create an open system where a Johnson Controls thermostat could operate a Honeywell valve. And this interoperability fostered a competitive marketplace, but also it was a lesson that the industry would later have to painfully relearn. While pneumatic systems became the standard for commercial buildings, a design icon emerged in the residential market. That was the Honeywell T86, also known as the Round. It was released in 1953 and it became a symbol of post war comfort and modernism. Its simple but intuitive interface and forgiving installation made it ubiquitous, cementing the concept of a thermostat in public consciousness.
Fast forward 9 decades and the very air has changed. The thick, organic brew of coal and horse that defined the 1880s has been scrubbed away, replaced by the sterile, manufactured scent of the modern age. The air tastes of diesel exhaust and is punctuated by the faint, high-frequency hum of electricity. It's the harmony of a future realized. Step inside a new corporate headquarters, and the contrast to the past is absolute. The ornate, soot-stained masonry of the 19th century has given way to soaring monoliths of poured concrete and sleek, impersonal towers of glass and steel. The clatter of hooves on cobblestone has been replaced by the buzz of combustion engines on the asphalt far below. The interior is a world of synthetic texture, sculpted plastic chairs, low-pile nylon carpet in shades of avocado and harvest gold, and vast expanses of vinyl-covered partitions that create a maze of cubicles. The light is no longer the warm, singular glow of an incandescent bulb, but the cool, shadowless, and perpetual flicker of fluorescent tubes that hum with a steady, almost subliminal drone. The new frontier is not mechanical, but informational. In the office, a revolution is quietly unfolding. A secretary sits not before a clattering manual typewriter, but a Wang 2200-word processor. It's a beige, bulky machine with a small cathode ray tube screen displaying glowing green characters. It hums with an electric pulse, and the clack of its keyboard is crisp, precise, and somehow less human than the forceful strike of its predecessor. This is the world of the 1970s. A world that has traded the gritty, hands-on challenges of the industrial age for the abstract, systemic complexities of the information age. The limitations are no longer about conquering the cold or bridging physical distance, but about managing overwhelming complexity and navigating the impersonal scale of modern life.
The year is 1971, and the world of building control is not silent. While it's not found on a screen, it is a tangible, physical, and audible world. Imagine, and you can almost hear it, the gentle, constant, reassuring hiss of hundreds of pneumatic lines, the lifeblood of the building, snaking through ceilings and walls. You can feel the floor vibrate with the reassuring thunk clunk of a massive centrifugal compressor kicking on and in the cavernous mechanical room in the basement. Our predecessors, the true pioneers of this space, were masters of a mechanical kingdom. Their primary tools weren't a mouse and a keyboard. They were a well-worn wrench and a pouch of calibration tools, and almost an intuitive understanding of pressure and flow. A building's logic wasn't stored on a microprocessor, rather it was meticulously engineered into a complex, sprawling web of copper tubing, sensitive diaphragms, and precisely calibrated bellows. The central plant was a masterpiece of mechanical engineering, a loud, proud testament to the power of steam, chilled water, and air. The building didn't just have an HVAC system, it had lungs, breathing through an elegant network of pneumatic actuators. Life was good, the work was honest, if a bit inefficient, but who's counting? Energy was an afterthought, really pennies on the dollar. Comfort was the undisputed king.
The American dream is running on fumes. The boundless optimism that once propelled a nation across continents and into gleaming skyscrapers has slammed into a wall of geopolitical reality. The defining scent of the decade isn't progress, but the sharp, acrid odor of gasoline spilled on hot asphalt, mingled with the exhaust of idling engines in lines that stretch for blocks, a daily, humbling testament to a world suddenly defined by its limits. The energy crisis had arrived, a slow-motion shock that permeated every corner of American life. The crisis is not a distant headline, it's a daily friction. It's the mandatory 55 that saves lives, speed limit signs on the interstate, turning the freewheeling highway, a symbol of post-war freedom, into a corridor of mandated restraint. It's the sight of gas stations shrouded in darkness, a hand-scrawled "No gas" sign taped to the pump, a stark visual punctuation of an era of scarcity. The heavyweight steel chariots of Detroit, the Impalas, the LTDs, with their massive V8 engines, suddenly seemed like dinosaurs, their chrome grills glinting defiantly in the sun as they thirstily wait their turn for a ration fill-up. News reports are filled with talk of megawatts and rolling blackouts, introducing a new vocabulary of vulnerability. The very light that banished the 19th century darkness feels finite. its source suddenly precarious, forward. Beyond the gas lines, other powerful world-shaping currents are flowing. The environmental movement, born from the smog-choked cities and polluted rivers of the post-war boom, is coming of age. The first Earth Day at the decade's dawn was not a fleeting event, but the start of a profound shift in consciousness. For the first time, the bill for a century of industrial expansion is coming due. Simultaneously, the world is shrinking and fracturing. The monolithic Cold War continues its icy standoff. A constant murmur of nuclear tension pulsates beneath the surface of daily life. Yet, society's tectonic plates are shifting. The world is no longer a simple binary of East versus West. Fuel-efficient cars from Honda and Toyota, clever electronics from Sony are flooding American shores, challenging the once unquestioned dominance of American manufacturing and signaling the dawn of a truly globalized economy. This is the America of the late 1970s, a nation grappling with its hangover from a 20th century feast. The era is a study in contradiction. Astronauts have left footprints on the moon, yet citizens are unable to freely buy a tank of gas. The challenge is no longer about inventing the future from scratch, but about navigating the complex, interconnected, and fragile world that those inventions have created.
And then, in what felt like an instant, everything changed. On October 19th, 1973, the OPEC oil embargo began. Now, some of you may remember the shot heard around the world, and others learned about it in the years that followed in history class. The shockwave hit the global economy, and the aftershocks rattled the very foundations of our industry. Suddenly, folks on the top floor, the executives who had never set foot in the boiler room, were coming down, faces grim, their briefcases weighted down with worry. They came in with a new, terrifying, and accusatory question: how much does this cost to run? Energy was no longer a cheap and simple utility. It was a strategic and potentially catastrophic liability. The days of keep it comfortable were a thing in the past. The order from on high was now a frantic, desperate plea. Comfortable is nice, but for God's sakes, make it cheap. The entire industry was put on notice. The old pneumatic kingdom, for all its brute force reliability, was a complete black box of energy consumption. We knew it worked, but we had no idea how much fuel it was burning in the process. We needed to see inside. We needed a brain. We needed a way to measure, to analyze, and to control with a precision we never had before. And into that void stepped the Titans. Now, this wasn't a battle of products. It was a fundamental clash of ideologies, a technological holy war fought on bid sheets and in smoke filled specifier meetings across the country. In one corner, you had the undisputed heavyweight champion, the old guard, Honeywell. Their weapon of choice was the Delta 1000. This system was the epitome of centralized command and control, an evolution of their earlier electronic systems. It was a massive, imposing console that looked like something out of a Cold War movie, a behemoth of steel and indicator lights. The entire philosophy was built on bringing every possible data point back to one central, all knowing location. An operator, often a senior technician who earned his stripes, would sit in the chair and monitor a sea of green, yellow, and terrifyingly red indicator lights. If they were lucky, they'd get a printout from a chattering teletype machine, a furious clatter of keys on paper detailing what was happening on floor 17. The Delta was powerful, it was established, and for many risk averse building owners, it was the safe bet. It represented brute force centralization. In the other corner, you had the hungry, innovative challenger Johnson Controls. They saw the writing on the wall, looked at the future, and decided to bet the entire farm on it. In 1972, they launched the JC80, and it was a bombshell that rocked the industry. Why? Because it was the first building automation system built around a dedicated mini computer. Think about that for a second. Honeywell was deep in the world of hardwired logic panels and relay switches, and Johnson comes to the table with a computer. The JC80 could offer a cathode ray tube display, an actual screen. You weren't getting you weren't getting cryptic printouts. You were seeing floor plans and data points in near real time. A blinking green cursor promising a new era. You could program sophisticated start-stop schedules, duty cycling routines, and load shedding sequences that were impossible with purely mechanical or electronic systems. This was a monumental leap, giving building owners their first taste in true automation, not just centralizing. God damn it. Okay, I'm going to just start the whole thing over. That's fine. Yep, I'd rather do that at this point. So I know that most of it was good, but that's fine. In the other corner, you had the hungry, innovative challenger, Johnson Controls. Oh, sorry. Okay. All right. Well, good that we're re-recording it. Okay. In the other corner, you had the hungry, innovative challenger, Johnson Controls. They saw the writing on the wall, looked at the future, and decided to bet the entire farm on it. In 1972, they launched the JC80, and it was a bombshell that rocked the industry. Why? Because it was the first building automation system built around a dedicated mini computer. Think about that for a second. Honeywell was still deep in the world of hardwired logic panels and relay switches, and Johnson comes to the table with a computer. The JC80 could offer a cathode ray tube display, an actual screen. You weren't just getting cryptic printouts, you were seeing floor plans and data points in near real time, a blinking green cursor promising a new era. You could program sophisticated start-stop schedules, duty cycling routines, and load shedding sequences that were impossible with purely mechanical or electronic systems. This was a monumental leap, giving building owners their first taste of true automation, not just centralized monitoring. And lest we not forget the wild card in the ring, the Powers Regulator Company, which would be known as a number of companies before finally being acquired by Siemens. Their Powers System 600 utilized an ASCII-based protocol for communication and was a respected, highly capable competitor that kept these two giants honest. Powers had a fiercely loyal following, particularly among mechanical engineers who prized their solid, no-nonsense engineering. They were often a dark horse, the craftsman's choice, ensuring that no contract for a landmark skyscraper was an easy win for either Honeywell or Johnson. The battle was ferocious. A win on a project like the Sears Tower wasn't just about revenue, it was about a massive billboard to the world. It was marketing gold. Sales teams would live or die by their ability to prove, or at least convincingly promise, greater energy savings than the competition. The energy crisis had, in a few short years, turned the mechanical trade of building control into a high stakes, high tech race to the moon. So you have these new electronic brains, and at the time, it almost seemed like wizardry. How did they make them think? In the academic world, you had programming languages like Fortran and COBOL, but you couldn't just drop a computer science graduate into a mechanical room and expect them to program an air handler sequence of operations. The very DNA of our industry was deeply rooted in the mechanical and electrical trades. This is where the quiet genius of adopting ladder logic comes in. Borrowed from the world of industrial programmable logic controllers, or PLCs for short, ladder logic was the perfect bridge between the two worlds. It was a visual programming language that looked almost exactly like electrical relay logic diagrams the technicians had been reading and troubleshooting for 30 years. The concept of rungs, contacts, and coils were already second nature. They could trace the flow of the logic if the contact is closed and that the contact is closed. Then energize this coil in a way that actually felt tangible and intuitive. It meant the guy who spent Monday with a wrench and a pressure gauge calibrating a pneumatic actuator could spend Tuesday in front of a programmer building its digital replacement without having to become the software developer overnight. It was the single most important factor in the successful deployment of these early DDC systems. It was an act of empathy in engineering. And as the decade closed, the microprocessor arrived and it changed the game once again. The computer no longer had to be a refrigerator sized mini computer in the basement. This technological leap allowed us to create the very first true direct digital controllers that could put the intelligence out at the zone level, right next to the equipment it was controlling. It was the beginning of the end of the monolithic central brain and the birth of distributed control. But this victory, this incredible new capability, created a new kind of chaos. Every system was a proprietary walled garden. A Honeywell front end couldn't just talk to a Johnson controller. A power system with its own sovereign nation. As a building owner brought into a vendor, you were locked in, from the sensors in the ductwork to the software on the screen. The frustration among facility managers and building owners was palpable. They had seen the power of digital control, but now they were trapped by its proprietary nature. A new tower would be built with one system, and in addition, 5 years later, would be forced to install a completely separate, incompatible system requiring different training, software, and spare parts. And right there, in the simmering frustration of those late 70s pioneers, that the next chapter of our story was written before it even happened. The need, the absolute, the burning necessity for an open standard was born not out of desire for technical elegance, but out of sheer operational pain. The great battle of the 70s had set the stage for the next great movement, the one that would eventually give us BACnet and an interconnected world we have today. So next time you click through a graphical front end, seamlessly integrate a new piece of third-party equipment, or drag and drop a logic block on a screen, take a moment. Remember the hiss of the pneumatic lines. Picture the operator watching that teletype spit an alarm from the 40th floor, and give a nod to the giants who battled it out, and to the technicians who, armed with the beautiful simplicity of ladder logic, dragged our entire industry kicking and screaming into the digital age. Well, we really hope you enjoyed this story. Remember to stay curious and never forget the pneumatic hiss. Until next time, I'm Charles.
And I'm Matthew.
And this has been It's a Controls Problem. It was an act of oh my God. Empathy. I'm not going to.
But as the decade of limits bled to a close, as the last gas lines dissipated into memory, a new light began to glow on the horizon. The language of business was changing from memos and meetings to spreadsheets and data streams, all moving at the speed of light through newly threaded wires, snaking through the walls. What happens when every office has its own brain? What happens when the brute force system of the past learn to listen, to process, and to optimize themselves in real time? Join us for part 2 of A Tale of Intelligent Buildings as we enter the sleek glass towers and mirrored boardrooms of the 1980s. The era of analog control is over, the digital dawn is here, and for the first time, the building itself is beginning to think.